want to give a little background so I can put this in context. I mostly started working a little bit with fire as a way to avoid slash pile impacts and how can we not burn slash piles, or and I'll talk a little bit later about how to build better slash piles. But what I wanted to do was figure out a way to use low value woody biomass to create something that was more useful. And so I got to work on biochar. And for those of you who aren't familiar with biochar, it's just intentionally made charcoal that is applied for land amendment, for soil amendments. And I wanted to figure out what were the lasting impacts of putting this charcoal out on forests and range and wineland sites, and could we use it as a tool? And so what I won't talk about today is that charcoal's really great at doing a couple things. One, besides water, we're going to talk a lot about that, but one is that it limits invasive species, because invasive species really like nitrogen, and carbon ties up nitrogen in the soil, and so it limits invasive species, so that's a bonus, right? And it also is a great place for fungi to hang out. And when I first started working for the Forest Service, that was our big thing, was how much wood do you leave on the soil surface to make sure that you maintain productivity in the future. And a lot of you are familiar with the leave 10 tons per acre of woody biomass after harvesting, and that was my boss's work on the Corm experimental forest. And so that's how I kind of got going on this organic matter charcoal scene. So, but you guys all know, you've seen pieces of wood like this in a lot of fire ecosystems. And so a lot of the discussion lately, though, has been that if we've suppressed fire for so long, there probably hasn't been a lot of that charcoal input into the soil, and maybe that's one of the reasons why we have invasive species problems, and why the soil is not as healthy as it could be. So that was one of the reasons that we started looking at biochar as a way to increase charcoal in the soil. So there's a couple benefits, and I love these SEM photos because you can kind of see the pores in charcoal, and that's really the key to holding water and nutrients, and where fungi hang out is that when you create charcoal, you create these pores, and that's a stable source of carbon in the soil, and it's a great way to it resists decay, and so it's there for a long, long time. You know, we've dated charcoal that's been there for 10,000 years in different ecosystems. Maybe it only lasts for 100 years, but it's a long-term carbon source. And so if you don't take anything else from my talk today, I want you to take this infographic home with you, that if you can increase organic matter in the soil by 1%, it's not very much, you can increase the water holding capacity by 25,000 gallons of water. And that's a huge number, right? When you start thinking about climate change and how a lot of our ecosystems are stressed for water. Or if you think about snow melt in the springtime and you get a lot of runoff, and if our soils could hold more water, how we could temper that runoff rate by holding it in the soil longer. And so, you know, one of the things about this is, well, you know, how do we start to build in forest sites? How do we build organic matter? It's true in agriculture too, but in agriculture they can, you know, till in organic matter. In forests we kind of have to let it sit on the soil surface, and we, you know, we have to have a lot of patience. Vita mentioned this, that you have to have a lot of patience when you talk about forest soils. And so one of the things we did when we first got started with biochar is we thought, where could we make the biggest impact with charcoal in the soil? And of course it's the pumice soils in Oregon, right, where there's no organic matter. And so we did this little core study. We added biochar at a rate of about 2.5 tons per acre, which doesn't seem like a lot. Maybe it's about an inch of charcoal on the soil surface. Did some cores, added water, and you can see that biochar added about 20% increase in water holding capacity in these pumice soils, which is huge, especially if you think about long summers and changing the water dynamics. We were able, when we put this out on forest sites, we were able to keep grass green into August on these sites because of the added organic matter. And so that could be huge, right, for forage for wildlife, for storage of water in general, for keeping trees growing, for in a post-fire landscape where you want to get seedlings to reestablish. Having this carbon source in the soil could be huge for getting seedlings to make it through their first year. So I know it's not all about biochar, so I'm going to transition a little bit into natural fires and talk about some work that's been done. So here's Ponderosa pine forest with prescribed fire and thinning. We can form charcoal at a pretty high rate during a fire, 1 to 10%. And this work that was done was that short fire return intervals in a Ponderosa pine forest yielded about the same amount of charcoal as a longer return interval in a lodgepole pine forest. And so, here's the charcoal produced at wildfire was, 0.15 to 1.5 tons of carbon per acre. So that is kind of on the same scale as what we were trying to mimic when we put biochar out on forest sites. And here's some work that was done down in the southeast on available water with amounts of charcoal that were added to the soil. So here's 0, and it goes all the way to 50 with the purple bar. And you can see how percent water changes from 0, it was at about 12%, and at 50 grams per kilogram of soil, we've increased water holding capacity up to about 18%. That's a 6% difference in available water in soils, in that soil. So it's an easy thing to do, and I think the repeated fires, we can continue to add charcoal and increase water holding capacity, because I think for a lot of these sites, it's really needed. So I want you to, I always like to challenge you a little bit. So we're going to do some math. So remember those algebra problems if you're running down the road at 15 miles per hour and a train's coming, when you climb. So if a Ponderosa pine forest burned in the past 10,000 years with a fire return interval of 35 years, that's about 285 fires, and we generated about 3% charcoal from each burn, and the charcoal is about 80% carbon, then there's approximately 32 tons per acre of carbon in the soil. That's huge. That's a huge increase. It's not all there, of course. Some of it's been eroded because it's right on the soil surface. Some of it could have been burned in a subsequent fire. But you could expect that about half the charcoal that was produced would eventually make it below ground. So that's about 15 tons per acre of charcoal that could eventually be put below ground. It decomposes over time. If all of that charcoal were there, it's pretty noticeable, right? You'd be able to see it. But some of it does move on. And some of it breaks down pretty rapidly to be smaller particles that we don't even really notice very much, but it's still performing some pretty valuable functions. So here's another example. This is from some work that Tom DeLuca had done in lodgepole pine forests. So you can see there's these pools of above ground, surface fuel, forest floor, and mineral soil charcoal, about 215 megagrams per hectare of carbon. And it can go two ways, right? Thinning and no fire, or and then a crown fire, where you end up with about 188 megagrams, a decrease from the original. Or thinning and surface fire, and then 10 surface fires over this 200 years, where you end up actually with an increase of about 3 megagrams per hectare of carbon in the soil. So where the fire burns and how it burns is really critical for where does that carbon end up and how much ends up in the soil. And then here's another example from Yellowstone. This had standing biomass of about 40 tons per acre of carbon. Charcoal was formed at a rate of about 8% of the coarse wood, about 9 tons per acre on the ground, and it yielded about 1.5 tons of charcoal. That's that, we talked about that earlier in the example of about 1.5 tons per acre of carbon. And what does that do for water holding capacity? So lots of opportunities. And then reburns. So I did a small study in the Scapegoat Wilderness a while back, looking at soil carbon and what happens after 1, 2, and 3 burns. And here's some work from Ward, who also did it similar in the Bob Marshall Wilderness, mixed conifer forest. Once burned, black carbon was about 250, 300 tons per acre, and twice burned was about 600. So, pretty big increase in those places where we have reburns. And here's some work, kind of a mash together of a bunch of people's work, but basically showing the same thing. Here's the forest floor. No burns have about 100, 4 times as much with 1 or more burns in the forest floor. We don't see it so much in the mineral soil. Like I said, you have to have patience for this stuff to work through. And we've noticed that with the biochar, which is a pretty uniform particle size, that it takes about 4 or 5 years for us to pick it up in the mineral soil when we surface apply it. And so you can imagine that with the wildfire and the chunky burn, chunky charcoal that you get, it would take even longer to, to have litter fall on top of it and to work its way, get small enough to get through the soil particles into the soil. And then just another example of some restoration treatments with fire surrogate. The big increase in charcoal comes when we thin and burn. And it's often seen first in the forest floor. And so one of the other benefits of having charcoal in the soil and having a nice place for fungi to hang out is that you build soil aggregates. And so once you build those aggregates, they kind of get to be sticking together a little bit better, and then you don't see as much of erosion. And you also, I pointed out the popcorn pumice soil because that's a great example, because there's no organic matter, and whatever you add is really great, wonderful. And so you can see here that it is texture dependent. It's not just that we see the same thing everywhere, but you'll see sandy is this blue line, loam is the green, and silty soils are the kind of greenish color. I don't know what that is. But in all cases, you can see that as you increase carbon content of the soil, you also increase available moisture. And I think that's probably key to a lot of the ecosystem changes that you see. And it would be interesting, Cameron was talking about feedbacks. And I don't think that paper in 2011, the Westerling paper, mentioned anything about soil and what happens when you change dynamics in the soil. And so that would also be interesting to start working that into Cameron's new model. Was that a deer in the headlights look? And so, so I told you at the beginning that I got into this gig working on slash piles and can you build better slash piles? And yeah, we can build better slash piles, light them from the top, quench the flames when the fire's kind of getting ready to go out, rake out the charcoal. But check this out. So this line here is where we raked charcoal and where we didn't. This is August, and you can see the site where we raked out the charcoal from the fire is green, and this part's brown. Maybe you can't see that very well, but it's true, brown. And so like I said at the beginning, that kind of gives you some ways to think about how we change soil processes when we change the organic matter in the soil. So I made up some implications for forest management. Prescribed fires and wildfires both increase soil carbon. And the amount of carbon produced is pretty variable depending on past fires and harvest operations and when the fire occurs and how much charcoal gets made. But I also mentioned earlier that this increase in soil moisture from carbon additions can really alter not only the quantity of stored water, but also the quality, because charcoal is a great filter, right? When you go camping, you suck through the charcoal filter straw. It's a great way to change the quality of water. And Mike had mentioned earlier about all of those people downstream from where these fires are occurring. And if we can change the quantity and the quality of water that moves downstream, I think we're doing the right thing by people. And I think that adding carbon to the soil also is a great way to prevent erosion, so we have less soil moving into our water courses. And keeping plants green longer into the growing season is one way to mitigate severe wildfires, but also to keep forests available for wildlife. And so, lots of benefits. So, my big summary. Charcoal is a great stable source of carbon in the soil, and we can add carbon like nobody's business with prescribed fire and wildfire. And I think those are the key things to keep in mind, particularly in ways that help us store water and maintain water in the ecosystem. But from my point of view, it's a great way to build resilient soils and resilient forests, because I think if we can keep water in the soil longer, we also have trees that are healthier and are better able to resist disease and insects and aren't so prone to dying when the fires come through and are not drought stressed. So, so it's a lot of benefits that we can see by adding charcoal to forest soils. So here's biochar in case you've never seen it. Have any questions? Yeah.
I was just wondering, does the increased water holding capacity, is it great enough to affect denitrification in the soils? Like, do you see more?
You know, we haven't seen denitrification happen. We know that it ties up nitrogen on those pores, but we haven't really seen a denitrification problem in forest sites. It could happen probably in agricultural sites where they're demanding more. But we've had sites going for, our longest one is 11 years, and we still haven't seen a problem with loss of nitrogen yet.
Cool.
Yeah, thanks. Yeah.
Do you have any sense the impact that soil carbon might have on allelopathic chemicals and subsurface? You think something like knapweed, and might it take away some of its edge?
We hope so. We have some, we had some study plots on the Sealy district, and we were trying to actually build mycorrhizal fungi in the soil to help get trees established. But we haven't gone back for 5 years, and so that's on our list of things to do, is to go back and see. But yeah, biochar is really great. It ties up pesticides and herbicides, and I would guess allelopathic chemicals as well. But a lot of work hasn't been done on forest species yet. Yeah.